Good morning, everyone. Today I'm going to present on virtual machines versus container from an operating system's perspective. Virtualization has become one of the most important technologies in modern computing, whether it is cloud computing, data centers, or software development. Virtual machines and containers play a major role. In this presentation, we'll understand how both technologies work, compare them with an operating system's perspective, and discuss their advantages, limitations, and real world applications. Let's begin with the basics. Virtualization is a technology that allows multiple isolated computing environments to run on a single physical machine. It helps to improve hardware utilization and reduces infrastructure costs. Containers are lightweight form of virtualization. Instead of virtualizing hardware, they virtualize the operating system by sharing the host kernel. This makes them faster and more efficient than traditional virtual machines. In traditional computing, one physical server usually ran on one operating system. This resulted in poor utilization of hardware resources because many servers remained idle for most of the time. To solve this problem, virtualization was introduced. It allowed multiple operating systems to share the same hardware efficiently. Later, containers evolved to provide even better performance by eliminating the need for multiple operating systems. A virtual machine is a software based version of a physical computer. Each virtual machine has its own guest operating system, applications, and virtual hardware. A hypervisor creates and manages these virtual machines. Since VM run a complete operating system, they provide strong isolation and security, but they also consume more CPU, more memory, and storage resources. Containers are different from virtual machines because they do not include a separate operating system. Instead, they package the application along with the libraries and dependencies while sharing the host operating system's kernel. This makes containers lightweight, portable, and much faster to start, making them ideal for cloud native applications and microservices. This slide compares the architecture of virtual machines and containers. In virtual machines, every VM contains its own guest operating system above hypervisor. In containers, all the containers share host operating systems through a container engine such as Docker. Because containers eliminate the extra operating system layer, they require fewer resources and deliver better performance. From the operating system's perspective, virtual machines and containers achieve isolation differently. Virtual machines virtualizes the hardware. Each VM has its own operating system and kernel. Containers use operating system level virtualization. They share the host kernel but maintain isolated user spaces. This allows multiple applications to run independently while using fewer system resources. The kernel is a core component of the operating system. In virtual machine, every guest operating system has its own kernel. This provides excellent isolation but increases memory and storage usage. Containers share host operating system's kernel. As a result, they are much more lightweight, faster, but they cannot run on different operating systems simultaneously. Process isolation prevents application from interfering with one another. Virtual machines achieve this through separate operating system and the hypervisor. Containers use Linux namespaces to isolate processes, networking, users, and file systems, while control groups or C groups manage CPU and memory allocations. This approach provides efficient isolation without running multiple operating systems. Resource management is one of the operating system's primary responsibilities. In virtual machines, the hypervisor allocates dedicated CPU, memory, storage resources to each VM. Containers share the host operating system, kernel, and use C groups to efficiently manage CPU and memory usage. Therefore, containers consume fewer resources and start much faster than virtual machines. Now let's compare the performance and security. Virtual machines offer stronger isolation because each VM has its own operating system. This makes them more secure for sensitive workloads. Containers provide better performance due to the lightweight architecture and faster startup time. However, because they share the host kernel, their security depends on proper configuration and kernel protection. Both technologies have their own strengths. Virtual machines are ideal for running multiple operating systems, legacy software, and highly secure environments. Containers are perfect for cloud computing, DevOps, continuous deployment, and microservices because they're lightweight, portable, and scalable. The choice depends on the application's requirement. This table summarizes the major differences between them. Virtual machines virtualize hardware, whereas containers virtualize the operating system. VMs offer strong isolation, but they consume more resources. Containers are lightweight, start quickly, and provide better performance. Today, many organizations use both technologies together depending on the workload. The future of virtualization is closely connected with cloud computing. Containers are becoming the standard for cloud native applications, while Kubernetes automates container deployment and management. Many organizations now adopt a hybrid approach by combining virtual machines for security and containers for speed and scalability. Emerging technologies like AI driven infrastructure and edge computing will further enhance virtualization. To conclude, virtual machines and containers are both important virtualization technologies, but they solve different problems. Virtual machines provide strong isolation by running separate operating systems, making them suitable for secure and multi OS environments. Containers provide operating system level virtualization, offering faster startup, better scalability, and efficient resource utilization. Choosing the right technology depends on the application security, performance, and deployment requirements. Thank you.